Okay, so now we're going to focus on graphing quadratic functions, and we're going to do part today, and then we'll finish it Tuesday and Wednesday. Now, there are going to be two forms of the quadratic function that you're going to have to be able to graph. One's going to look like this. So let's suppose I want to graph f of x equal x minus 4 squared minus, let's say, 4, something like that. Let me make it x minus 2 minus 4. So this is a quadratic function because if you were to follow this out, you get an x squared, right? Okay. The other kind of quadratic function, the way it's written, that you have to be able to graph would be something like this: f of x equal 2x squared minus 3x plus 4, something like that. So notice that both of those are quadratic functions. Both are quadratic functions, except they're written differently. One's written like this, the other one's written like this. The one that's written like this is called one thing, and the other one is called a different thing. I don't want to tell you what those two things are until we kind of look at a graph of this one to begin with. So let's go ahead and graph this one. Now remember, a quadratic function, on the last test, some of you thought that a quadratic function was a line. When you go back to your test that you just took, test number 2, there were about 3 of you, maybe 4, that when you graph that quadratic function, you graphed a line. Is a quadratic function the shape of a line? No, it's the shape of a parabola. And I even told you on the test that this was a quadratic function. I didn't tell you it was a linear function. I said it was a quadratic function. All right, so this is quadratic. Let's plot some points and see what the shape looks like. So if x is, let's say, 2, I'm just picking some numbers here. Just write these down. If x is 2, I get 2 minus 2, which is what? 0 squared is, and then 0 minus 4 is negative 4. So I get 2 negative 4. So let's say 2 negative 4 is right here. All right. If x, let's say, is 3. If x is 3, what's 3 minus 2?
1.
And what's 1 squared?
1.
And what's 1 minus 4?
3.
Negative 3. So I get the point 3, negative 3. If x, let's say, is 5. 5. What's 5 minus 2?
3.
What's 3 squared?
9.
What's 9 minus 4?
5.
5. So I get the point 5, 5, which is about here. If x, let's say, is 0, what's 0 minus 2?
Negative 2.
What's the negative 2 times itself?
4.
And what's 4 minus 4?
0.
So I get 0, 0. If x, let's say, is negative 2, what's negative 2 subtract a negative 2?
Negative 4.
What's the negative 4 times itself?
16.
What's 16 minus 4?
12.
12. I don't have enough room here. So let's use negative 3. Let's use negative 3. If x is negative, negative 3 is going to be too much either. So let's use negative 1, I'm sorry, negative 1. What's negative 1 subtract 2?
Negative 3.
What's negative 3 squared?
9.
What's 9 minus 4?
5.
5. So I plot the point negative 1, 5, which is here. You have enough points there to where you can draw the parabola. So this point right here, negative 2, 2, negative 4, what point is that? That's the vertex. So you get something that looks like this. All right, so that is the graph of f of x equal x minus 2 squared minus 4. So that's a vertex. Okay, now What is the vertex in this case?
2, -4.
2, -4, right? So y'all agree that the vertex is 2, -4. Remember, when you label a point, you put that parentheses. You notice I put parentheses there. Vertex is 2, -4. Do you see 2, -4 anywhere in your function? Yes. I see 2 and -4. I see 2 here, and I see -4 here. We call this, the way it's written, we call this the vertex form. So this is called the vertex form. So whenever it's written as f of x equal a times f of x equals a times x minus h squared plus k. Whenever it's written like this, whenever the quadratic function looks like that, whenever it's in that form, we call that the vertex form. So vertex form, it's always in the form a times x minus h squared plus k. Now, I'll give you that form. You just need to be able to know how to use it. Okay? Now, some textbooks call it standard form. So vertex form or standard form. Vertex form or standard form. Whenever it's written in vertex form or standard form, the vertex is h comma k. Your vertex is h comma k. That's your vertex. So whatever h is, that's the x-coordinate vertex. Whatever k is, that's the y-coordinate vertex. So let's look at this then. I'm going to write a bunch of functions there. You may want to leave some space. We're going to come back and add to it. So let's suppose I had this function here. And let's suppose my function is g of x equal 2 times x minus 5 squared plus 3. What form is this? Vertex form, standard form. What is the vertex of that quadratic function?
5, -3.
5, positive 3.
Positive 3, okay.
5, positive 3. X minus h. What's h? 5 plus k. What's k? 3. So your vertex is 5, 3. Okay? Leave some space here. Number 2. H of x equals -3 times x minus 4 squared minus 6. So if that were my quadratic function, and again, what form is this? Vertex form. What's going to be the vertex?
4, -6.
4, -6. Okay, 4, -6. Number 3, suppose I had k of x equal 1/2 times x plus 3 squared plus 5. What is the vertex? Huh?
-3.
-3,
No, 5.
5.
Yeah.
-3, 5. Because remember, the vertex form doesn't say x plus h. What does it say? X minus h. So you got to remember this expression x plus 3 from many years ago means the same thing as saying x minus a what? -3. So x minus h. So what's h? -3. So you have to know what that vertex form looks like. Vertex form is x minus h. All right, so your vertex will be negative 3 comma what? 5. Okay. All right, now, let's look at this one. Let's look at this. Suppose I want to graph g of x equal negative 2 times x plus 3 squared plus 5. I'm making this up, so the numbers won't, hopefully they won't be that big, so we can deal with it. All right, so we're actually going to graph this, but now I know what the vertex is. What's the vertex?
Negative 5.
Negative 3, 5. That's my vertex. So right away, I can go and plot the point negative 3, 5. So negative 3, 5 is in the second quadrant right here. So that's my vertex. Okay? Now, remember, your vertex is right in the middle of where that high or low point is. And remember in a previous lesson we talked about an even function? An even function was symmetrical about the what?
Y-axis.
Y-axis. And so when we graphed x squared, that was an even function. When we graphed it, it was symmetrical about the y-axis. That y-axis went right through the what? Vertex. Went right through the vertex. Now, obviously, in this case, the y-axis is not the axis of symmetry. All right? But the idea is that the vertex is right in the middle of where the two curves depart. So I'm going to draw this line. See this dotted line? This dotted line, draw a dotted line. And that dotted line is called the axis of symmetry. All quadratic functions have an axis of symmetry. All quadratic functions have an axis of symmetry. Okay, all quadratic functions have axis of symmetry. Now, whenever you look at graphs of quadratic functions, you don't ever see that dotted line at all. When you look at your math book or go online, Google quadratic functions, it's usually just that parabola. But you're going to draw the axis of symmetry to help you graph the parabola. All right? Because remember, when we talked about the even function, it was symmetrical about that y-axis. So when I graph this, my parabola is going to be symmetrical about this axis of symmetry. Now, listen carefully. The axis of symmetry is what kind of line? Vertical. Okay, vertical. How do you name a vertical line? What's the equation of a vertical line? X equal a number. What is that number that crosses the x-axis?
Negative 3.
Negative 3. All right, so remember some things you learned in the previous course, that a vertical line is named, the equation is always x equal a number. Y is not there. That's why it's vertical. And so here, the axis of symmetry, right here, is x equal negative 3. In fact, I'm going to put this up here. We found the vertex, right? What was the vertex? Negative 3, 5. The axis of symmetry always goes through the what? Vertex. So once you know the vertex, you know the axis of symmetry is always x equal that x coordinate. What's that x coordinate? Negative 3. All right, so all quadratic functions are going to have an axis of symmetry, so it's not In the previous lesson where we graphed that x squared and we saw that it was symmetrical about the y-axis, is it always symmetrical about the y-axis? No. So your axis of symmetry is always going to, you're always going to have an axis of symmetry. It's always going to be this x coordinate. So my axis of symmetry here is going to be x equal -3. You use that to help you graph. So that's why, remember, it's not, keep in mind that it's not part of the parabola. We use it, though, to help us graph the parabola. So that's why we put a dotted line. All right, and we plot a few more points and you're done. You're done. So let's use the t-table. I'm going to do that here. T-table. So all I need for you to do is to give me maybe 2 points to the right and 2 points to the left. That's all you do. Give me 2 points to the right, 2 points to the left of that vertex. So if x is -3, give me another value, another x value to the right. -2, okay. So if x is -2, let's see what we get. What's -2 plus 3?
1.
What's 1 squared?
1.
What's 1 times a -2?
-2.
What's -2 plus 5?
3.
3. So I'll plot the point -2, 3. -2, 3. Give me one more number to, oh, let me just go ahead and do this. They're going to ask you, I want you to notice this, all quadratic functions will have a y-intercept. So let's find the y-intercept. All quadratic functions will have a y-intercept. All quadratic functions will have a y-intercept. Okay, so since it's going to have a y-intercept, remember, how do you find your y-intercept?
Say x is 0.
Let x equal 0. Okay. So let that be one of your points. Let x be 0. All right, now listen carefully. You're almost done. If x is 0, what's 0 plus 3?
3.
3 squared?
9.
9 times a -2? -18 plus 5? -13. I don't have enough room. I don't have enough room.
Yeah, it was funny when she said meaning there.
So but that would be one of those that you would whenever I give you your function, the y-intercept will be in this plane. So let's just pick another point then. Let's say 1. I don't want to use 1 either, because what's 1 plus 3?
4.
4 squared? 16 times -2 is a pretty big number, right? So let's use -1. Hopefully that will work. -1. What's -1 plus 3?
2.
2 squared?
4.
4 times -2? And -8 plus 5?
-3.
-3. So -1, -3 is right here. Okay, now before we go on, let me just say this. Remember, all quadratic functions have a y-intercept. Now, just like we talked about previously when we did the exponentials, what was the domain of an exponential?
Negative infinity.
So all real numbers. So x was in there. X equals 0 is in there, right? So it has a y-intercept. The same thing is true for a quadratic functions. Remember, the quadratic functions either go up or they go down. The domain is still what? Negative to infinity. So x equals 0 is always in that number, in that domain. So you always have a y-intercept. So one of the blanks will be the y-intercept. So if I don't say rise in the ordered pair, then you can just say what? What was it, -13? If I say rise as an ordered pair, then you have to say what? 0 and -13. Okay. All right, now here's what you do. Remember we did the even function x squared, and we talked about the distances from that point to the y-axis? Do the same thing here, the idea of symmetry. So listen carefully. See this point right here? How many units is it away from the axis of symmetry?
1.
So I better have something on this side that's 1 unit away, because it has to be what? Symmetrical. Over here, how many units is this?
2.
How many units do I need here? So you're done. Draw your parabola.
No, young ladies do their homework, you get it wrong. You did not do that.
Oh, Don't get it wrong. Those are easy points to get.
To do that on my test, because I didn't know I didn't want to do all the work.
Okay, so you see, that's all you do. Use the axis of symmetry, use the idea of symmetry to help you like the other points and draw a parabola. Now, you remember when we talked about relative max, relative min? The one we did a while ago, is there a relative max or relative min?
Relative min.
Relative min. Over here, is there a relative max or relative min?
Max.
Relative max. Okay? The one we did a while ago, the parabola opened up. Over here, the parabola opened down. It's pointing down, so we say it opens down. Here, it's pointing up. We say it opens up. Now, let's go back to the vertex form here. So you may ask, well, how do you know from the function whether it opens up or down? It's very easy to determine. A, the value of A will tell you if it opens up or down. The value of A. The number that's in front of x minus h squared. Over here, what's this number in front of x minus h squared? 1. Over here, what's the number in front of x minus h squared? Negative 2. All right, so listen carefully. If A is positive, the parabola opens what? Up. Parabola opens up. If A is positive. If A is negative, less than 0, the parabola opens down. Okay? Parabola opens down. So if the parabola opens up, then we're going to have a relative minimum. If the parabola opens up, we have a relative minimum. Let me go ahead and write that here. So if the parabola opens up, kind of makes sense because if you look at it, this vertex is going to be a relative what? Minimum. All right, so we have relative min. If the parabola opens down, we have a what? Relative max. That kind of makes sense because if it opens down, this is a high point, right? So it's a relative max. Okay. All right, now let's go back. To these three right here. So let's look at number 1 again. So one of the things you have to be able to do on MyMathLab and when graphing these is determine the vertex, which you now know how to find the vertex. Now notice that all of these are in what form? Vertex form. So that's why it's easy. That's why it's easy to determine the vertex because it's already in what form? Sometimes they call it standard form. So vertex form. So we know how to find the vertex. Now the next one I asked you is the axis of symmetry. What's the axis of symmetry in number 1?
2.
Nope. But you don't just say 5. You're going to say what? X equal 5. What's the axis of symmetry in number 2? Okay. What's the axis of symmetry in number 3? X equal negative 3. Okay. All right, now let's go back and look at those two graphs that we just drew. So these quadratic functions, what's the domain of these quadratic functions?
Negative infinity to infinity.
So all real numbers, right? Negative infinity to infinity. So the domain is all real numbers. As an interval, negative infinity to infinity. Now, the range is not the case. On test number 2, I gave you the graph of the quadratic function. I asked you to find the range from the graph. If you go back to test number 2, you'll see it. What is the range in that first graph up there?
-4 to infinity.
Okay, now some of you still have an issue with domain and range in terms of parentheses, brackets. Do I need brackets or parentheses here?
Bracket on the first.
Brackets, because that vertex is a point of graph. You see an open circle there? Is there an open circle there?
Nope.
No, it's a closed circle. It's part of the graph. But remember, the range is at y value. What's that y value? -4. So my range is bracket -4 all the way to what? Infinity with parentheses. So listen carefully now, because in the 3 problems we're going to look at, what we're looking at, the graphs aren't there, right? So listen carefully to what I'm saying about this one. All right. Number 1, did the parabola open up or down? Opens up. So my vertex is at a relative max or relative min? Relative min. So my range is going to go from there all the way to what? Infinity. So you got to visualize that. But remember, with the range, you always talk about your y value. So what's that y value in that vertex? -4 all the way to what? Infinity. Okay. Let's look at this one. What's the domain from the graph? I'm sorry, the range from the graph? -infinity to 5 is the range. The domain is always going to be, yeah. So the range is from -infinity all the way to what y value? 5 with a bracket. Okay, let's talk about, now you looked at it from the graph. You're not always going to be given the graph. You're not going to be asked to graph it. But you will still be asked to determine the range. So all you do is determine whether it opens up or down. Does this, and I think it was number 2, right? So if I go back to number 2, right here, does that open up or down? Opens down. So in your mind, visualize it. Visualize this thing opening down. Visualize it opening down. So this is a what? The vertex is a max, a relative max. So my range is going from -infinity all the way to that y value of that vertex. What's that y value? 5. Okay? So the range is from -infinity to 5. All right? Now, let's go to those 3 problems. The graph's not there. What's the domain on all of them? Yeah. So all of them, -infinity to infinity. Okay. Let's talk about the range. Let's go to number 1. Does the graph open up or down? Graph opens up. Why? Because A is positive. And what's A in this case? 2. Okay, good. So the parabola opens up. Since A is positive. So you know since it opens up, you know it does this. In your mind, you have that shape. So that vertex is a relative what? Minimum. The vertex is a relative minimum. So my range is to go from that minimum all the way to infinity. What's that y value? So 3 is the y value, is that right? Yeah. So your range is going to be what? 3 to infinity. That's all you do. Notice You did not need to know what the graph looked, you did not have to actually draw the graph, you just in your mind knew things about it. Or number 2. What do you think the range is? Say it again? -6 to infinity? Okay, so let's think about it. So does the graph open up or down? Opens down. So the parabola opens down. So in your mind, it looks something like this. So it's a relative max. And so that's going to be your highest y value, right? So you're going to go from negative infinity all the way to that highest y value. What's that highest y value? -6. With a bracket. All right. And then final number 3. Does the parabola open up or down? Opens up. Parabola opens up. Since A is positive. A greater than 0 means A is positive. So in my mind, I have something that looks like this. So this vertex right here is a relative min. So that's going to be my smallest y value. So I'm going to go from that all the way to infinity. So what's the range? Bracket 5 to infinity. All right, and then remember, in my domain, I always have x equals 0, right? So what else can I find for those 3 functions? The y-intercept. Before I go on, no one asked, well, why are we finding the x-intercept? Well, for one reason, it's for the ones I just did, they're pretty complicated to do. But not all of them have an x-intercept, right? So if I go back to this graph right here, oops, actually, both of them did. Both of these have an x-intercept, right? But are they always going to have an x-intercept? Nope. Watch. Look. If my parabola is in the first quadrant, let's say, or above the x-axis, and it goes up, do I have an x-intercept? Nope. But I'm always going to have a what? Y-intercept. If the parabola is in the third or fourth quadrant, it opens down. Am I going to have an x-intercept? No. So are you always going to have an x-intercept? No. But you're always going to have a y-intercept. So that's why they're always going to ask you to find the y-intercept. So let's go here and find the y-intercept. To find the y-intercept, I'll let x be what? 0. What's 0 minus 5? What's negative 5 squared? What's 25 times 2? 50 plus 3? So y-intercept is 53, or 0, 53. Over here, y-intercept. You let x equal what?
0.
What's 0 minus 4? What's negative 4 squared? 16 times a negative 3? Negative 48. Negative 48 and negative 6? Negative 54. Remember, I make these up. That's why they're as they are. All right, next one. Y-intercept. Let x equals 0. What's 0 plus 3?
3.
3 squared?
9.
9 times a half is 9 halves, or 4.5, right? 4.5? You agree? 4.5 plus 5? 9 and a half. So my y-intercept's 9 and a half, or 0, 9 and a half. Okay? Yes?
On the test, if you put 0, 9.5, will we get it wrong?
Yeah, no, because 9.5 terminates, so you're fine. Now if this was 9 and a third, then you wouldn't want to say 9.3, because it's 9 and a third, 9.3. You learned that, when you were almost going into first grade. Is 9 1/3 9.3? No, what is 9 1/3? 9.3333 and so on. It repeats. All right, so you got to know when to when to rise the decimal and when not to. All right, 9.5 terminates, so you're fine. So in 9, if this were 9 1/3, you would leave it as 9 1/3.
And then you want it in parentheses or by itself with yes or
If I tell you to write it as an ordered pair, then it has to be in what? Parentheses. It has to be as an ordered pair. If I don't say anything, then you are okay to just say what? 9 1/2. So that's where reading the directions are important. Okay? All right. Now, let's look at this. So all we've done at this point was dealing with quadratic functions that was written in what form?
Vertex form.
Vertex form or standard form. Okay? Now before we go on, let's do one more problem with this idea, but now we're going to graph. So on your worksheet, on your test, on your final, you may have something like this. You may. Okay, so let's graph. So let's put it all together. We're putting it all together. Let's graph this quadratic function. G of x equal -3 times x plus 1 squared minus 2. All right. What form is this?
Vertex.
Vertex. So since in vertex form, you can tell me the vertex. What's the vertex? Very good. -1, -2. If you didn't see it was -1, and you said 1, you better talk to your neighbor. Because remember, it has to be in the form x minus h. So x plus 1 is really x minus a what? -1. So that's why h is a -1. What's the axis of symmetry? Nope.
Actually, x equals -2.
X equal -1. -2 is the y coordinate, David. Okay. Does the problem open up or down? Opens down. Why does it open down?
Got a negative.
Because of A. What's A in this case? Okay. Since A is negative, it's going to open down. All right. Let's find the Y-intercept. It always has a Y-intercept. 0, comma. What's 0 plus 1? What's 1 squared? 1 times -3?
-3.
-3 and a -2? -5. So my parabola is going to cross the y-axis at -5. Am I going to have any x-intercepts here? No, because where's the vertex? I mean, what quadrant is the vertex? Or actually do this. Is the vertex above or below the x-axis? It's below. Does the parabola open up, open down? Down. So will it cross the x-axis? No. So always keep that in mind as you graph. All right, so let's graph. Now, before we go on, because I want you to be able to do this without looking at the graph, what's the domain? Okay. What's the range?
Negative infinity to -2.
Yeah, so remember, your parabola opens down, right? And the vertex here is -1, -2. So that's a relative max. So my my range goes from negative infinity all the way to this y value, because we're talking about range. Range is a set of y values. What's that y value? Negative 2. So negative infinity to negative 2 with a bracket. Okay, so let's go ahead and graph this. Use symmetry to help you now. Okay, so my vertex is negative 1, negative 2. I'm going to draw my axis of symmetry. Here's my axis of symmetry. Make sure it's a dotted line. And I know that the y-intercept is 0, negative 5, so that's right here. So now listen, right away I know, if I know that this point's on the graph here, right here, if I know that's on the graph, then I know another point on the graph.
-2, -5.
-2, -5. But I need for you to do 2 more points. So give me another x value, and let's just go to the right. Let x be what? 1. All right, if x is 1, if x is 1. What's 1 plus 1?
2,
What's 2 squared?
4,
What's 4 times? I'm not going to have enough.
-12.
-12. -12 and -2 is a -14. So that didn't help me. Let's use, we already did -2. Yeah, in fact, I'm not going to have enough. If I use integers like 2, so, all right, so at that point I would just do this. I would just, yeah, just make it look symmetrical. It looks symmetrical, so we're good. Because if I were to use x equal 1, 2, 3, and so on, it would be off the coordinate plane. You see what I did? I used the axis symmetry to help me. Some students will do this. I'm telling you now, some students are going to do this. Watch, they'll do this. And hopefully it won't be any of you, but might. So -1, -2 is here. -1, -2 is here. And then we found 5 and 0, right? Axis symmetry. And this is what some of you are going to do. Does that look symmetrical? No. If you draw a graph and it doesn't look symmetrical, you're lucky if you get 1 point. All right? And it's got to be a curve, right? So make sure it's got to look like a curve. This is not a curve right here. So make sure it looks like a curve and it's symmetrical. All right? So this needs to be symmetrical. So whenever you plot your points and it doesn't look symmetrical, what does that mean? You did something wrong. Don't turn that in like that.
It'll be happy.
All right. What? No. I would never sing about anybody. All right, so a while ago, at the beginning of class, I gave you those 2 functions. Remember that? Okay. And I should have named this in a different function, so let's just call it g of x. So f of x, and I'll rename the other one g of x. F of x is in what form? Vertex form. When it's vertex form, you can easily do all this stuff, right? Because one of the things, when graphing a parabola, one of the things you have to find is the vertex. You have to find the vertex. That's one of the things you have to find when graphing a parabola, when graphing a quadratic function. G of x, is that vertex form? No. That's not vertex form. That's just a regular trinomial, right? Okay, that's called general form. So this is in general form. So that's general form, and this was in vertex form. Sometimes called standard form, depending on your textbook. General form, you cannot look at general form right away and say what the vertex is. But there's a formula you can use to find the vertex. All right, I'm going to look at that formula tomorrow. All right. Now you know that's general form, right? So you know the difference between vertex form and what? General form. Vertex form, that's what we just did. All this stuff we just did. That was easy to deal with. General form, can you tell me what the vertex is right away? No. But you can, I'll say this, you can tell me if the graph opens up or down. It opens up. Because remember when we talked about quadratic functions, when we talked about quadratic functions, just remind you, it was ax squared plus bx plus c. Remember that? Well, what letter tells you whether it opens up or down?
A.
A. The coefficient of x squared. And what is a in this case?
2.
2. So it's going to open up. All right? So that you still can determine right away whether it opens up or down. So remember, if I were to FOIL this out, wouldn't I get x squared times this 1 right here? All right, so the same idea here. All right, this is A, this is A. All right, okay, so we're going to do the formula. There's a formula that you can use with general form to find the vertex. Once you find that vertex, everything's the same as the rest. You can do it just like the rest. Okay, so we do that tomorrow.